if you believe that consciousness is a requirement, consciousness as humans perceive it is a requirement for building machines that can actually achieve human level intelligence and cognitive abilities. And if yes, if you think consciousness can be computationally reduced to computation, basically.
Okay, so I have a funny opinion about consciousness. I don't think it's that important. I think it's an illusion due to the way our brains and our minds are organized. Basically, my hypothesis, which is not a theory, okay, which is very much a hypothesis, is the fact that I was talking about the world model in my talk. So the world model in the human brain is the prefrontal cortex. It's the entire front part of the brain. And the thing is, we cannot have a universal world model for every situation we will encounter. So, but we have basically a single world model engine, a single piece of hardware, that's our prefrontal cortex. And so probably what's happening is that there is some way of configuring our prefrontal cortex to handle the situation at hand, okay? And because we have a single engine for our world model, we can only accomplish a single conscious task at any one time,
okay.
Right? So we can accomplish a lot of subconscious tasks simultaneously, right? Yeah. We can drive a car and do all kinds of things simultaneously, listen to radio, whatever. Because that doesn't require our prefrontal cortex to be particularly active. It doesn't require a world model, right? Because those tasks have become kind of subconscious, automatic. What psychologists call system one. Now, as soon as we're trying to accomplish a task that we're not used to, that or requires some, reasoning or planning, then we need to use a world model. And there, we can only solve one such problem at any one time. We can't do multiple tasks simultaneously when we do this. So that suggests that we have only one conscious engine, if you want, like a world model that we can configure for the task at hand. So now, if we have this configurable world model, we need some sort of module to configure it, right? So we need a module that kind of sits on top of everything else in our brain and configures our brain for the task at hand.
And that's consciousness.
Well, that gives us the illusion of consciousness, okay? But it's a side effect of the fact that we only have one world model engine. If we had a brain that was 100 times bigger, perhaps we would have like 100 different world models, and we wouldn't need a configurator to kind of configure the brain for that. We wouldn't have consciousness, but we'd be smarter. So, people associate consciousness with sort of high intelligence. I just think that's false. I think consciousness is actually a consequence of the limitation of our brain.
Actually, my question is also regarding the world model, because to me this idea is fascinating, of finding a way to abstractly represent our environment, our action space. So, do you believe that it is possible to come up with such a theoretical formulation without having a bit more insight into the lower level processes of our brain, so that then we can use it to perform inference and so on, to include it in the pipeline for the objective-driven AI that you proposed? Okay,
so one characteristic of objective-driven AI versus the most current AI systems that are used today, with a few exceptions, is the fact that the output is not computed by running through a fixed number of layers of a neural net, right? An LLM, any LLM, is a transformer with 40 layers or 90 layers, whatever it is, and you give it a prompt and it produces one word by just running through those layers. That's it. So the amount of computation that's devoted to producing a token or word is constant. And so what that means is that those systems cannot devote more resources to solving more complex problems than to simple problems. It means they can't really reason, right? And that process of running through a fixed number of layers is not Turing complete. You can't represent like every single function this way, at least not with a ridiculous amount of resources. So now compare this with objective-driven AI. So objective-driven AI, the way the output is computed is by optimization, right? There is a cost function, which may be complicated to compute because you have to go through a world model and objectives, blah, 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 and observe the world. But it's done by an optimization process that finds a set of output variables that minimize a set of objectives. That is Turing complete. You can reduce every computation to an optimization problem. And of course, when the problem is more complicated, the optimization will be more difficult and the system will take longer, right? So there you have the kind of property you observe in humans and animals where you have to think about something longer for things that are more complicated, but it's more powerful in the end. So those are, it's a fundamental difference between sort of feed-forward inference and then inference by optimization. Now, this concept is not new at all in AI. Things like Bayesian networks, factor graphs, things like that. They do inference by minimization of a negative log likelihood, but it doesn't matter. And that's intrinsically more powerful than just running through a feed-forward net. But then, is this what goes on in the brain? Not clear. Do we have to copy the brain? The answer is no. For the same reason, airplanes don't copy birds. They use the same underlying principle, but they use it in different ways, right? So it's the same idea. You want to get inspiration from neuroscience, but not reproduce it because you don't know which details are important if you don't know the underlying principle, right? If you look at birds, you might think that flapping wings is important or that feathers are important. But they're not. What's important is how you generate lift by pushing an airfoil through the air. So it's the same question for AI. What's the underlying principle that is at the basis of intelligent behavior?